Choosing between SQL and NoSQL is one of the most critical decisions a developer makes when architecting a system. On one hand, you have SQL, the battle-tested veteran of the industry. On the other, NoSQL, the flexible, high-speed alternative designed for the modern web. But why does it matter? If you pick the wrong one, you might find yourself battling slow query times or complex data migrations a year down the line. Today, we are breaking down the architectural differences, scaling strategies, and the real-world scenarios where each database shines. From ACID compliance to horizontal partitioning, we will look at how data is stored, retrieved, and scaled across clusters. By the end of this video, you will have a clear decision matrix for your next project. Let's dive into the world of relational versus non-relational data storage.
Let's start with SQL, or Structured Query Language. These databases are relational, meaning they organize data into tables with predefined schemas. Think of it like a rigid spreadsheet, where every row must follow a strict format. SQL databases excel at handling complex queries and maintaining data integrity through ACID properties. That stands for atomicity, consistency, isolation, and durability. This makes them the go-to choice for financial systems or any application where data accuracy is non-negotiable. If you are building a banking app, you cannot afford for a transaction to partially complete. SQL ensures that either the entire transaction succeeds or nothing changes at all. Popular choices include PostgreSQL, MySQL, and Microsoft SQL Server. However, this structure comes with a trade-off. As your data grows, scaling vertically, adding more power to a single machine, eventually hits a physical and financial ceiling.
Now, let's look at NoSQL. Unlike SQL, NoSQL databases are non-relational and offer a more dynamic schema. They come in various flavors, such as document stores like MongoDB, key value stores like Redis, and graph databases like Neo4j. The primary advantage here is flexibility. You can store data without a predefined structure, making it perfect for rapid development and evolving data models. But the real superpower of NoSQL is horizontal scaling. Instead of buying a bigger, more expensive server, you simply add more cheap commodity servers to your cluster. This is achieved through sharding, where data is distributed across multiple nodes. This makes NoSQL the king of big data in real-time web apps where you might have millions of concurrent users. However, you often trade off immediate consistency for availability and partition tolerance, a concept known as the CAP theorem. In a NoSQL world, your data might be eventually consistent rather than instantly consistent. To understand the choice, we must look at how data is modeled. In SQL, we use normalization. We break data into multiple tables to reduce redundancy. If a user has multiple addresses, we create a users table and an addresses table, linking them with a foreign key. To get the full picture, we perform a join operation. Joins are powerful but computationally expensive as the dataset grows. In NoSQL, specifically document stores, we often do the opposite, denormalization. We embed the addresses directly inside the user document. This means a single read operation retrieves all the data you need with no joins required. It's incredibly fast for reads, but it means if an address changes, you might need to update it in multiple places. This highlights the fundamental trade-off. SQL optimizes for storage efficiency and consistency, while NoSQL optimizes for speed and developer agility. Which one fits your data's natural shape?
SQL truly shines when your data structure is stable and you need complex query capabilities. If you're building an ERP system, a CRM, or a financial platform, the relational model is your best friend. SQL's ability to perform deep analysis across multiple tables using declarative queries is unmatched. It also provides a high level of security and standardized interfaces. Because SQL has been around for decades, the ecosystem is massive. You'll find endless tools, drivers, and experts. If your application requires multi-row transactions where data must be consistent across different entities at the exact same microsecond, don't even look at NoSQL. Stick with a robust relational engine like PostgreSQL. It's better to have a slightly slower, perfectly accurate system than a lightning-fast one that loses track of a customer's payment.
On the flip side, when is NoSQL the right call? Choose NoSQL when you are dealing with large volumes of unstructured or semi-structured data. Think of social media feeds, IoT sensor data, or real-time analytics. If your data model changes every week as you pivot your startup, NoSQL's schemaless nature will save you from the nightmare of constant database migrations. It's also the clear winner for applications that need to be globally distributed. If you need low-latency access for users in London, Tokyo, and New York, NoSQL databases like Cassandra or DynamoDB are built from the ground up to replicate data across geographic regions effortlessly. In these scenarios, having the latest post show up 500 milliseconds late is a fair trade for the app never going down. If you prioritize availability and scale over strict relational constraints, NoSQL is your engine of choice.
What if you need both? This is where modern architecture gets interesting. We call this polyglot persistence. Most large-scale applications today don't use just one database. They use a SQL database for core business logic and user accounts, while using a NoSQL database for caching, session management, or logging. For example, an e-commerce site might use PostgreSQL to manage orders and inventory, ensuring every item sold is accounted for, while using Elasticsearch for their product search and Redis to store temporary shopping carts. By combining these technologies, you get the best of both worlds, the rigid consistency of SQL where it matters, and the blistering performance of NoSQL where speed is king. Don't feel pressured to pick a single winner. Instead, pick the right tool for each specific microservice within your system. As we wrap up, let's look at the decision matrix. Ask yourself 3 questions. First, is your data structured and predictable? If yes, SQL is likely the winner. Second, does your application require high-frequency writes and horizontal scaling? If so, NoSQL is your best bet. Third, how important is immediate consistency? If you need every user to see the exact same data at the exact same time, SQL is the safer choice. Remember, the gap is closing. Modern SQL databases like Postgres now support JSON-B for NoSQL-like flexibility, and some NoSQL databases are adding ACID transaction support. The SQL versus NoSQL debate is becoming less about which is better and more about which is the most efficient for your specific workload. Take the time to profile your data patterns before you commit to an engine.
Database technology is constantly evolving, but the core principles of relational and non-relational data remain. Whether you choose the structured reliability of SQL or the fluid scalability of NoSQL, understanding these trade-offs will make you a much better engineer. If you found this breakdown helpful, hit the like button and subscribe for more deep dives into system architecture. What's your go-to database for a new project? Let me know in the comments below. Thanks for watching, and I'll see you in the next one where we explore how to optimize your database queries for maximum performance. Keep building, keep learning, and keep scaling.